Hello all, welcome back to our channel. In this session, we'll discuss about the structure analysis. In structure analysis, let us see the continuous beams. So in this session, we'll see what is continuous beam, how to draw the bending moment diagram due to external loads and support moments. Also, which theorem is applied to analyze these continuous beams. Okay, now let us see first what is continuous beam. So in generally, the continuous beam means for definition wise here, which is the beam supported with more than two supports, then generally the type of beam is called as continuous beam. So here I am taking a continuous beam A, B, C, D. These are the four supports. Then generally for a beam, AB is one span, BC is one span, CD is one span. So in these four supports and three spans are there. So four supports means it is more than two. So generally these type of beams are called as continuous beams. Now here I am applying on this continuous beam a uniformly distributed load from A to T, equally distributed over the all the spans, and this uniformly distributed load is W per unit length. In this W per unit length, due to this external loading, here the deflection curve will be there. Now let us draw this deflection curve. So at the supports, and here A and D are the end supports and B and C are called as intermediate supports. So this is the deflection curve. This curve is called as deflection curve. This is due to external loading. So here you have to observe at the end supports A and D the deflection will be different, and at the intermediate support the deflection will be different, and at the mid of the span the deflection will be different. So here the deflection curve is having convexity upwards over the intermediate supports and concavity upwards over the mid of the span. So here this is the deflection curve, and the bending moment diagram is also drawn into different total bending moment is depends upon the one, and one is due to support moments and one is due to external loading conditions. So here in the analysis of continuous beam, to draw the bending moment diagram, you have to calculate the bending moment values due to support moments as well as due to vertical loads, means external loads. These are the two. Based on these two values, calculation of and analysis of bending moment and draw bending moment diagram will be there. And in this continuous beam, we have to use to analyze these continuous beams. The theorem name is Clapeyron's theorem of three moments equation. So here Clapeyron's theorem of three moments equation. This, by using this equation, we solve this continuous beam. Clapeyron's theorem of three moments. So here how to apply this theorem, it is depends upon the end supports. Let us, if in case the beam is simply supported ends, there are two different ways. One is fixed end, the theorem will be different, and the theorem will be different for simply supported ends. Let us see, if in case the beam is simply supported end points, then the theorem will be applied. If in case span AB, then the theorem is MA L1 plus 2 MB L1 plus L2 plus MC into L2 equals to 6A1 X1 by L1 plus 6A2 X2 by L2. So here this is the equation, and some textbook 6A1 X1 bar and 6A2 X2 bar will be there. So here what is the 6A1 and A2? All these are, we'll see in problem how to apply this theorem in the analysis. This theorem equation is Clapeyron's theorem of three moments equation. In this session, we'll not discuss about the derivation point. Just we'll see what is theorem equation for a simply supported ends. For exam point of view, how to analyze for a simply supported. Let us solve one problem in next session. Thank you.